Okay, section 8.2, proving triangle similarity by angle by AA, which is angle, angle. Okay, so our objective for this lesson is to use the angle-angle similarity theorem, solve real-life problems. Okay, so in the last section, 8.1, we talked about similar polygons, what that means as far as their side lengths, their perimeters, their areas, their angles. Okay, we know similar figures have congruent angles. Similar figures have proportional sides, okay? But we haven't really talked about how do we go about proving two things are similar. Okay, so today we're going to learn one theorem in proving two triangles are similar. So this is the angle-angle similarity theorem. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are congruent. So over here in this picture, here we have angle A. Here has one mark. Angle D has one mark. So if we know if angle A congruent to angle D, angle A congruent to angle D, and if you notice, then we have another angle congruent here. We have angle B congruent to angle E, angle B congruent to angle E, then we know, so we have two angles, then we know that the triangle, this triangle ABC is similar to triangle DEF. And again, remember we have angle A and D lining up coming first, B and E coming next, and then C and F, oh, that should be an F, not a P, D, E, F are similar. So this is really a really shortcut way of proving two triangles are similar. Again, remember this only works with triangles. Okay, so this doesn't work for 4, 5, 6-sided figures, only with 3-sided figures. Okay, and we have to know that two angles of one are congruent to two angles of the other. So here in this example, determine whether the triangles are similar. If they are, write a similarity statement, explain your reasoning. So here, well, it looks like this angle, let's call, this is missing a point, let's go X. Here, angle X is 21 and angle R is 21. So we have one set of angles. We know angle X is congruent to angle R. Oh, we're missing a point here. Let's put that as an S. So this is X, Y, Z, and R, S, T. Okay. So we have X congruent to angle R, but we need two angles. Okay. Well, this angle Z here is 99, but I don't have a 99-degree angle over here. So we do have, so far, we've got this angle congruent to this one, but we need two angles. So we're actually going to have to find the missing angles in this triangle. But I know in a triangle, all the angles add up to 180. So if we're looking at this triangle, I can find this missing angle by taking 180, subtracting 99, and subtracting 21. 180, subtracting 99, subtracting 21. So this angle is 60 degrees. Okay. And then here I can find angle S here by doing the same thing. 180, subtract 61, subtract 21. And this angle here is 98 degrees. So here I have a 21-degree angle that's congruent, a 60-degree, and a 99. This one's a 61-degree and a 98. So do I have two angles of the one congruent to two angles of the other? No. So are they similar? No. The triangles are not similar. Not similar. There are not two angles in triangle XYZ congruent to two angles in triangle RST. Okay. All right. Okay, sometimes it's helpful, especially with compound triangle problems. And this problem here, there's actually three triangles. There's the big one, QPRQ. There's this little one up here, QTP. And there's this one here, PTR. So there's actually three triangles here. We want to show that triangle QPR, QPR, the big one, is congruent to QTP. QTP, this little one. So I'm actually going to draw these as two completely separate pictures. So here is QPR. There's my 90-degree angle there. Okay. And then we have QTP, and I'm going to orient it the same way. Okay, so there's my 90-degree angle. So if we're looking at QTP, my 90-degree angle is at T. The shorter side goes from Q to T, so this would be Q. And the longer side goes from T to P. That would be P. So here we have Q, P, R, and Q, T, P. Okay. But if we notice, this angle Q is the same angle in both of them. It's this angle here. It's angle RQP. Okay, so there we have angle RQP is the same as angle TQP. Is the same as angle TQP. T to Q to P. They're the same angle. RQP is the same as TQP. So angle RQP is congruent to angle TQP. By reflexive, they're the same angle. Okay. And we also have here angle P, angle QPR. Angle QPR would be congruent to angle QTP because they're both right angles. Right angles are congruent. So here I have two angles congruent. I know this little angle here, this angle Q, is congruent to this angle Q, right there, reflexive. And we know this angle P, this angle T, right here, P and T, okay, because they're both 90. So I have two angles. So I've just now shown triangle QPR is similar to triangle QTP because of the AA similarity theorem. Again, it's very important to notice these are similarity theorems, not to be confused with our congruence theorems. Okay, if you remember from previous sections, we had our congruence theorem, side, angle, side, 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 HL theorem, angle, side, angle, and angle, angle, side. Those are all our congruence theorems. This is a similarity. A very important difference there. It's a similarity theorem. It's proving two things are similar. Okay. All right, a school flagpole. Okay, so a school flagpole casts a shadow that is 45 feet long. So here I have the sun up here is shining down. I've got a flagpole. Here's the ground. So here's my flagpole. Okay, and it's going to cast a shadow here because it's going to block the sun in this triangular manner. It's going to create this shadow. Flagpole is 90 degrees. A school flagpole casts a shadow that is 45 feet long. So we know the shadow is 45 feet long. At the same time, a boy who is 5 feet 8 inches tall, so we also have a boy standing over here, is also going to cast a shadow. Okay, this boy is 5 feet 8 inches. The shadow here, that's 51 inches long. Okay, and he's standing upright. How tall is the flagpole to the nearest foot? Well, this angle with the sun, this sun is in the same spot for both him and the flagpole. So this angle here with the ground is going to be congruent because the sun isn't moving between the two. So that angle there is going to be the same. This 90-degree angle is also going to be the same. So I have similar triangles. They are similar triangles by the AA similarity theorem. Okay, so how tall is the flagpole? So since they're similar, their sides are in proportion. We're trying to figure out how tall this flagpole is. I'm going to label it as F, this height right here, from here to here. So since we have similar triangles, their sides are in proportion. So I'm going to go big over small. So this big, the flagpole, is taller than the boy. F over 5 feet 8 inches would be equal to its shadow, which is 45 feet. Oh, not 4 feet, 45 feet over 51 inches. Okay, but we've kind of got a bit of an issue because we've got feet and inches, feet, inches. We need to all be the same units. So I know that 1 foot is equal to 12 inches. So I'm going to convert everything to inches. So this 5 feet, I would need to take 5 feet times 12 inches. So that's 60 inches, and then add those extra 8 on. Add 8 inches onto that. Oh, well, it'd be 68. So we'd have F over 68 inches. Now 45 feet, 45 times 12 gets me 540 inches all over 51 inches, okay? So now I'm going to go ahead and multiply means extremes. So if you remember, here's our extremes, here and here. So we go ahead and multiply those. So I take F times the 51, so 51 times F. And then multiply my means, the 68 and the 540. 68 times 540, not a small number, but we can deal with it. 36,720. So then we need to take both of these and divide by the 51. So the flagpole, if I divide that by 51, we get 720. The flagpole would be 720, that's inches. Okay, we should probably want to convert that to feet, so take that 720, divide it by 12, which is 60 feet tall. So the flagpole is 60 feet tall, using that idea of similarity. Okay, so I want you to go ahead, flip this over. Notice that's it for notes. Okay, write down your practice back here, and good luck. Come see me if you have any questions.